Hello and welcome to .NET Conf. Over the next 3 days, you'll hear from our team, partners, and the .NET community about what's new in .NET and things people are building with .NET today to meet their needs of tomorrow. Our goal with .NET is to build a unified development platform that developers love and businesses trust. It enables developers to build any kind of application with best-in-class runtime, programming languages, development tools, and a vast ecosystem that is powered by amazing developers around the world. I want to thank all of you for the energy that you put into supporting and sustaining the .NET community, and of course, building on top of it. Now let's talk a little bit about .NET's momentum. We continue to grow at an astonishing pace. .NET is used by more than 6 million developers, and they're adopting the latest version of .NET faster than ever. Over 50,000 people have contributed to .NET till date. Not only are developers adopting and contributing to .NET, but they also love using it. We are the most admired framework on the Stack Overflow survey. C# is amongst the top GitHub languages, and we continue to be one of the highest velocity open source projects. We are so excited to launch .NET 8 today, one of our largest releases yet, and it couldn't have been done without you. Thank you for all your trust and contributions to help make .NET what it is today. Every single developer that is building with .NET, building open source libraries, submitting issues, fixing documentation, or helping drive the future as part of .NET Foundation, thank you. Now, let's go over to Damien and other members of our team to learn more about .NET 8.
Thanks, Gaurav. All right, it's another year, and that means another .NET release and another .NET Conf. .NET 8 is the biggest release of .NET yet, with improvements across the runtime, frameworks, and programming languages, including ASP.NET Core, Entity Framework Core, MAUI, Blazor, and C#12. Today, we're going to show you just a small taste of what we've got in store for you with .NET 8. Let's start out by looking at performance. Performance is very close to my heart and is always top of mind for each release of .NET, and .NET 8 is no different. For the last several years, we've been publishing a blog post that highlights the core performance improvements with each release of .NET. This year, with .NET 8, we are delivering more than 1,250 performance improvements. It's no wonder that blog post is getting so long. We'll touch on some of these improvements throughout the keynote today, but if you haven't read those posts, you should check them out. We've been sharing our progress on the Tech Empower web framework benchmarks for quite a few years now. With .NET 8, we're seeing improvements in the JSON API scenario of 18%, hitting nearly 1 million requests per second using ASP.NET Core minimal APIs. In the Fortune scenario, which is closer to a real-world workload including database access and server-side HTML rendering, we see an even larger improvement, 24%, hitting over 300,000 requests per second with ASP.NET Core. Our goal with .NET is to ensure that developers have a delightful experience. Building for the web, be it full-stack web apps or web APIs, building client apps that can run on desktop and mobile devices, and building powerful cloud-native apps that are resilient and scale to meet your demands. We'll cover some key features across these workloads this morning, but you'll hear a lot more about them throughout the rest of the day. Now, for the rest of this keynote, we're going to hear from members of the team talking about 4 key areas of .NET 8. Building full-stack web apps and APIs, crafting apps for mobile and desktop, infusing new and existing apps with artificial intelligence, and finally, how we are evolving .NET into a world-class platform for cloud-native development. To better highlight feature enhancements in .NET 8 in these workloads and more, the team has been working hard on a significant new iteration of the eShop architecture sample that we'll be highlighting throughout the keynote and throughout .NET Conf. This is a full-fledged reference app that utilizes cloud-native microservice architecture, fronted by some great-looking web and client applications. We're going to start by looking at full-stack web development, so let's head over to see Safia and Dan talk about what's new in ASP.NET Core in .NET 8.
Hey Dan, hey Safia.
Hey Damien.
I hear you're going to tell us about all the new stuff in ASP.NET Core for full-stack web development.
That's right.
Take it away.
Thank you, Damien. ASP.NET Core in .NET 8 has everything you need to build modern web apps. Whether you're building browser-based web apps or scalable back-end services, ASP.NET Core provides everything you need right out of the box. There's no need to stitch together a solution from multiple different frameworks.
That's right. You can be more productive by leveraging the same frameworks, languages, and tools for your entire app. ASP.NET Core is built for security and optimized for performance, so you can handle any scenario. With ASP.NET Core, every developer is a full-stack web developer.
ASP.NET Core includes Blazor, our front-end web framework for .NET. With Blazor and .NET 8, you can use the server and client together to handle all of your web UI needs. It's full-stack web UI. Blazor now includes enhanced server-side rendering capabilities, including static server rendering, enhanced navigation and form handling, and streaming rendering, so you can optimize page load time and elevate the user experience. You can then add rich interactivity wherever it's needed in your app, either from the server using Blazor Server or from the client via Blazor WebAssembly. Running your .NET code on WebAssembly from a browser is significantly improved in .NET 8. Components render 20% faster, there are lots of new edit types supported by Hot Reload, and a new web-friendly packaging format called WebCIL streamlines deployment. New built-in components for displaying data, for defining section outlets, and handling authentication help you stay productive and get the job done fast.
That's right. Now, as always, we take performance seriously, and those dividends pay off to you with lightning-fast APIs and services. ASP.NET Core is packed with new APIs in .NET 8 that allow you to be more productive, so you can focus on the code that matters most, yours. And if all that wasn't enough, Visual Studio and Visual Studio Code come with new tooling to enhance the developer experience. Let's see all that in action. We're just about ready to ship the eShop app, but there's one more API endpoint we need to add before we can do so. It's an endpoint that will allow our users to browse items in the catalog by their brand and type. Let's take a look at the code that I'm adding here. Now, the first thing I'll notice is that all of the route patterns in my code are lit up. This is thanks to the new route tooling in .NET 8. It allows me to see the parameters in my route template and any annotations that I might add. There's something else that's going on here too. You'll notice that I get a helpful warning about an unused route parameter in my code. In this case, it's this ID parameter right here. I can go ahead and remove this parameter to get rid of that warning. Fantastic, an analyzer that helps me write better code before we ship to production. Now, if we take a look at the implementation for my endpoint, we'll notice that it's taking advantage of quite a few services that are available in the DI container. I've captured these services into a catalog services type. Now let's go to definition on this type, and we're gonna spot something super nifty. It's the new primary constructors feature in C# 12. It's concise syntax that allows me to declare a constructor with parameters that are available in the entire body of the class. This is really helpful for types that take advantage of DI constructor injection.
That's really cool, Safia.
Yeah.
I gotta say though, but I can't help but be intrigued by this Visual Studio pane that you have on the left side there.
Yeah.
What is that?
Oh, great question, Dan. So this is the new Endpoints Explorer in Visual Studio. I can use it to browse all of the routes that are currently registered in my application. Now, what's pretty neat is that I don't need to build or run my application in order to see these routes. They're all discovered statically. Pretty nifty. But there's more. I can select any of the endpoints that I've created, here's my new one, and right-click to generate a request for it. This request will show up in Visual Studio's new built-in HTTP request client. Now I'm going to run my app. Great, now that my app is running, I can go ahead and click Send Request. And I'm able to send a request to my application and view the response right from within Visual Studio. I don't need another window at all. You know, I think we're almost ready to ship this new API, Dan.
Sounds great. But before we do that, should we do some testing on that API endpoint first?
Good point, Dan. I would never ship code to prod without writing tests. In fact, I've already gotten started on this. Let's head over to our tests. You'll notice that I've added a new test to exercise the API endpoint that I've just introduced. And I'm using another cool new C# 12 feature, collection expressions. Collection expressions are terse syntax that allow me to initialize collection values. In this case, I'm using collection expressions to provide a parameter to a method that takes an IEnumerable. Pretty nifty, right? Cool. Let's go ahead and run this test. Right-click, run test. Oh, darn, my test is failing. It looks like it was not able to find the route associated with the new endpoint that I just added. Let me go ahead and try and debug this. Now what I'm gonna do is set a breakpoint right here at the entry point for my application after I've registered all of the routes associated with my catalog API. Then I'm gonna start debugging my test. See if I can figure out what might be going on. Cool, we've just hit our breakpoint. Now what I'm gonna do is examine this app type right here. Now if you've got a keen eye, you'll notice that there's something new in .NET 8. The debugger display for this type and quite a few others in ASP.NET has been improved. In this particular case, I can take a look and examine the endpoints that are registered in my application. I can see the total number of endpoints and get information about the HTTP method, route template, and handler name that's associated with my methods and endpoints. Pretty nifty. It's a small detail that dramatically improves the debugging experience for my application. And in this case, I can use it to figure out that I think I might have made a typo in my test. It should be plural items in my route, not item. Let me go ahead and stop debugging, fix that typo, and rerun my test. All right, fingers crossed. Oh, great, a green check. The new test passed. All right, Dan, I think we're almost ready to ship to prod for real. But first, do you want to show us what we're doing on the front end here?
Yeah, thanks, Safia. That dev experience for building that new endpoint API looked amazing.
Totally.
All right, here's the UI for the web app. Here on the homepage, we can see the product catalog. And thanks to that new API endpoint that Safia added, we should now be able to filter on product types. Let's look at some footwear. Yes, it's working, and we should be able to filter on brands. Excellent. We can then pick one of these products and look at its details. This transparent hiking boot looks intriguing. It looks like it'd be great for showing off your sock collection. This whole web app is built using Blazor and Blazor components. If we bring up the browser DevTools, we can see how this is all working. Let's refresh the homepage. Okay, now let's filter on WebSockets. Do we have any WebSockets in this app? Nope, there are no WebSockets. What about WebAssembly? I'm not downloading any WebAssembly. Is there even any JavaScript? There's no JavaScript. This Blazor web app is being fully rendered from the server. So it's ready to load fast and scale. Blazor in .NET 8 supports static server rendering. Let's look at the code to see what that looks like. So here's the catalog component for that homepage. If we scroll down, we can see it looks like a normal Blazor component. But in this app, this component is set up as an ASP.NET Core endpoint that renders HTML directly in response to requests. With Blazor in .NET 8, you can handle all of your server-side rendering needs. Of course, Blazor can do much more than static server rendering. We can now use Blazor to enhance the page loading experience to make it much faster. To do that, let's go over here to the root component for the app, and I'm going to uncomment the Blazor script. We'll apply that to the running application. All right, so now if we go back to the app, so now when I filter, let's filter on footwear again, or on a particular brand. It's fast and it's smooth, and I don't lose my scroll position on the page. That's because Blazor is enhancing the page navigations and instead doing a fetch request. Right there. So instead of doing a full page reload, Blazor's intercepting the request, doing a fetch request, and then intelligently updating the DOM with the retrieved content from the server. This means we also don't have to re-download any style sheets, fonts, or other assets that were previously retrieved. My app feels fast and responsive like a single-page app, even though it's still using server-side rendering. Now we can enhance form requests too. To do that, let's add a couple of products to my shopping bag. Let's add maybe this watch. And first I'm going to have to log in. There we go. So now we can add this watch, the shopping bag. There it's showing up. Let's add a few more things. Let's add this bike helmet. Looks good. And then maybe also this backpack. Awesome. Okay, so we can see in our shopping bag, we now have all of our products, and we have these little forms that we can use to update how many of each product that we want to buy. For example, maybe I decide I want another backpack. Now, when I submit that form, you may have noticed there was a brief blip and I lost my scroll position. That's because it's doing a full page reload when I submitted that form. But with Blazor, we can do better. We can enhance that form post so it's much, much smoother. Let's go find that form in the cart page component. There it is. And I'm going to go ahead and enhance this form. Save that, and we'll apply it to the running app. Great. Now, if I submit this form again, let's click Update. You can see it's fast, it's smooth, and I no longer lose my scroll position. If we look in the browser tab tools, we can see what's going on with that form request. Again, when I submit, Blazor is intercepting that form request and doing a fetch request instead of doing a full page reload. And we don't have to re-download all of the web assets. So that's enhanced navigation and form handling. It makes my app feel fast and smooth, even though it's still doing server-side rendering. Okay, let's go back to the home page. Now on this home page, we have to download all of this product catalog data by making an API call. And that might take a little while. It's pretty fast in my development environment. Like if I just refresh the page right now, it's pretty quick. But when I deploy this to production, that API request might take a little while. To simulate that, let's go back to the code, and I'm just going to add a artificial task.delay to the catalog component for those times when the API request just takes a little longer than we hope for. Okay, let's go ahead and apply that to the running app. Now, if we go back, if we refresh the home page now, you can watch the tab up above. I click, about 1,000, and then it loads. Or if I apply a filter, let's filter on footwear, click, 1,000, and then it finally loads. We have this 1 second delay now while we're making that API call to get the product catalog data. We can make this experience better using streaming rendering in Blazor. To enable streaming rendering is really easy. We just go back to the component, and up at the top, we're going to add this stream rendering attribute. We'll go ahead and apply that. With streaming rendering, Blazor will render the component immediately with some placeholder content. Let's go ahead and refresh the page and see that. There, right there. You see how we can now have loading ... almost immediately while that API call is being made. Then, once the API call has been completed, Blazor will render the component again and stream the updated content down to the browser and patch it into the page. So you get those stream updates automatically. The page loads fast, and you see the streamed updates as they become available for a much better user experience. If I refresh now, we see loading, and then an automatic update.
That is pretty cool, Dan. Now, does that stream rendering require a WebSocket connection to work?
Nope, there are no WebSockets required at all. The streamed updates are actually sent on the same response that was used for the initial request.
Wow, that's nifty.
Yeah. Now, of course, with Blazor, we can also build richly interactive components. For example, this app has this store chatbot that I want to be a rich, interactive, and responsive user experience. We can do that in Blazor using either Blazor Server or Blazor WebAssembly, wherever in the app we need it, like just for this component. To show how you set that up, let's go find that chatbot component. Here it is. And all we need to do is apply an interactive render mode. I've already done that here using the new render mode Razor directive attribute. And then I'm here using interactive server rendering, which is Blazor Server. I'm also disabling pre-rendering in this case, and that's just because I don't want that chatbot animation of it sliding in from the side to happen twice. Okay, so that means that this chatbot is now an island of interactivity in an app that is otherwise just using server-side rendering. So we should be able to add a little question here, like, what is your best bike helmet? And we'll wait a second to see what it says. There we go. So now we got a response and we have a nice interactive chatbot. Now what's really cool is at the same time, I can still go over here and filter and browse the product catalog, and I don't lose the chatbot state. That's again, thanks to Blazor support for enhanced navigation. Also, if I close this chatbot, and let's bring up the browser DevTools, and let's see what happens when I open the chatbot. And now I'm going to filter on WebSockets again. Now we do have a WebSocket in this case because we're using interactive server rendering. And we can see that the WebSocket connection is active. It hasn't been closed yet. But once we close the chatbot, watch for it. There it goes. Now the WebSocket connection has been automatically closed and the request completed. We're only paying for interactivity when it's in use. Awesome. So our web application now has a great user experience and it looks fantastic. So that's how ASP.NET Core in .NET 8 makes it easy to build full stack across your entire web app.
Thanks. That was really great. It's amazing to see how far ASP.NET has come all these years.
That's right. Whether you're building web UIs with Blazor or backends with minimal APIs, ASP.NET Core in .NET 8 has everything you need to be more productive.
And that was just a small amount of the features in ASP.NET Core in this release. If you want to learn more about the other great features that we've been working on, check out the rest of the talks over the rest of this conference. Let's talk about client development for mobile and desktop with .NET. .NET MAUI is our platform for building mobile and desktop applications for multiple platforms. Use a single C# codebase and access native APIs to build world-class applications. We've seen great adoption of MAUI since we released it 18 months ago, and here to talk more about MAUI is Maddie.
Thanks, Damien. We have had so much fun seeing all the things you've built with MAUI so far. I have loved hearing about the apps and the projects, and of course all the feedback you've had, which is why in .NET 8 there were a few key areas that you told us were most important to you that we focused on. Not only has .NET 8's performance increased, but so has MAUI's. We've continued improving our overall startup time, our memory management, and our layout optimization across all of MAUI's platforms. Another really big focus has been on quality. We've squashed over 600 bugs and worked closely with our community to accept over 1,500 PRs across a bunch of different areas. Many of these were highly requested desktop app features and, of course, plenty of improvements when building Blazor hybrid apps with MAUI. More importantly, we could not be successful without you. We've been really grateful to our open source community members, our library maintainers, and our control vendors who have really come together to help MAUI's ecosystem flourish in the past 18 months. Now, my favorite thing to talk about with .NET 8 is developer productivity. We continue to ship amazing things in Visual Studio to make it easier than ever to build and debug and deploy your MAUI apps, but we also wanted to give you a lightweight, consistent experience across any development platform that you want to work on, which is why today I am excited to share with you the new .NET MAUI extension for Visual Studio Code. The .NET MAUI extension, alongside the new C# dev kit and updated C# extensions, makes it easier than ever to develop your cross-platform .NET MAUI apps in VS Code. It's currently in preview, so you can try it today, and let's take a look. So I am in the same eShop app that you saw from Safia and Dan earlier, but this is the MAUI version. So we rebuilt this to render with native UI controls on your desktop and mobile platforms. This one project has all of the code needed to run the app on iOS, Android, Mac, and Windows. It's part of the bigger eShop codebase, but I opened a solution with just the MAUI project so that we can look at those. And you can see that there's actually a solution explorer in VS Code. This is brought in from C# dev kit. It's able to show me my file structure the same way I'd expect to see it in VS Code. So my XAML files have their C# files nested in them and anything that you need there. You can see all of the different shared resources and platforms we're targeting in this app right in these folders here. So we have our resources folder and we have our platforms folder. And you can see we are sharing things from the app icon to images to even fonts all in one place with this code base. And we're targeting all 4 platforms that MAUI targets. And you have all of the platform-specific code you need right here in those folders too. So it's really easy to drop down and get to the native layer if you need to. So this is all part of the .NET MAUI, the C# and the C# dev kit extensions. All you have to do is install the MAUI extension. It will pull in the other ones for you, and we have all your instructions that you need to get set up. Once you have the MAUI workloads, you can then start writing your mobile apps and debugging them and trying them on any target platform that your device supports. So on my Mac here, I have Xcode installed and I have my Android SDK installed, so I can actually see all of those things when I zoom in down here to what we're calling our language status item. And it's telling me the project that I'm deploying to and also the target I'm deploying to. So I'm going to go up and pin this so I can see it. And then when I click on this that says my Mac, I can see all of the valid places I can deploy this app to. So I have my Pixel emulator, and then I have all of the different simulators that Xcode gives me. We are going to run this on my Mac. All I have to do is hit run and debug. If I want to create a launch JSON file, I totally can, but it's really easy to just hit run or hit F5 if that's what you like to do. Give it a second. And then you see that the debugger launches and the app is going to pop right up for me. So again, this is the same eShop app we were just looking at, but I rebuilt the UI in Maui. So it's a little bit different. I took some creative liberties with it, but I can just go ahead, add things to my cart, and then go look at my cart and see all of that in the total. If I pop up my iOS simulator alongside this, I already have the app running again, and you can see it's the exact same cross-platform. Even things like the app icon, this purple Northern Mountains logo, is the exact same as it is on my Mac. So it's all part of Maui. I didn't have to do anything custom to get that to work both places. And then I also customized the code so that on the cart page, there's a delete button only on the desktop app. Because on a mobile phone, I might want to swipe, right? Swipe to delete, that's something that people do. But on my desktop app, I probably don't want to swipe with my trackpad as much, so I just created this delete button. Does the same thing. And all I had to do to make that work was actually go into the XAML for my basket item and use a couple lines of code to create a button that says, on desktop, it's visible. That's it. That's all I had to do to customize this based on desktop or mobile apps. And thanks to C# Dev Kit, I can actually also go and see my testing project and run my unit tests right within Visual Studio Code. So I have everything I need right here to get started with Maui and to start working on all the different platforms. That has been a sneak peek into the .NET MAUI developer experience with Visual Studio Code. Like I said, it's in preview today, so you're more than welcome to download and try it out. And you can also join me and my teammate David Ortnow later this afternoon for a deep dive into all of the amazing features of .NET MAUI and .NET 8. Definitely make sure you check out the rest of the amazing Maui sessions at .NET Conf this year. Back at you, Damien.
Thanks, Maddie. So teams at Microsoft have been adopting .NET MAUI over this past year, including the Microsoft 365 admin app and the Microsoft Azure app, which have millions of downloads and excellent ratings across the platforms that they ship to. There are companies around the globe that have adopted .NET MAUI as their platform for multi-platform development. Let's take a look at the NBC Sports journey with .NET MAUI.
For the last 10 plus years, we have leveraged a multitude of Microsoft's engineering technologies. Specifically, the .NET platform has been as productive as it has been innovative for us and our products. As we continue to build cross-platform solutions across the board, we're always looking to become more and more efficient. And that's where .NET MAUI comes in. It has allowed us to coordinate and share code across web, mobile, and our APIs, leading to features being delivered to the market faster. Having used Microsoft's traditional cross-platform approach for mobile for more than 8 years, we have learned to streamline not only code productivity, but also better collaborate and communicate within our product and technology teams.
In 2022, our team embarked on rewriting the sports engine app. We were attracted to the .NET MAUI as it promises simpler and scalable development compared to other cross-platform frameworks. And with Microsoft fully behind MAUI, we decided to use it for this project. This choice helped us to finish the work much quicker, releasing the app in record time. The success of this project underscores MAUI's productivity boost, reaffirming our choice to embrace this technology.
In my experience, .NET MAUI is intuitive and a time saver. It opens up the door to integrate with Blazor on the web.
.NET MAUI has allowed us to unify our code base, making us highly productive and flexible.
That was a great video. Now let's change focus and talk a little bit about AI. In the last year, we've seen OpenAI generate a lot of excitement around the globe with developers thanks to the transformative power of AI to enhance their applications. I'm going to introduce Maria to talk a little bit more about .NET and AI. Thanks, Maria.
Thank you, Damien. Large language models like OpenAI ChatGPT have transformed the field of natural language processing and opened up new possibilities for software development. You can build amazing applications whether you are building a chat app, summarizing your data, or creating a translator seamlessly with .NET. But when you think about integrating AI into your application today, you as a .NET developer might be saying it's too complicated or too much code. Well, I have some good news for you. It's actually quite easy. The .NET team is making it simple for you to leverage AI in your applications today by continuing to provide first-class, out-of-the-box AI features in the .NET SDK, providing seamless integration with the Azure SDK so you can leverage Azure OpenAI and Azure Cognitive Search, as well as making it easy for you to integrate into these large language models with the Semantic Kernel SDK. But most importantly, we want to make sure that we meet you where you are. We are working with AI ecosystems across the world to deliver these emerging AI technologies, like vector databases, for example. We worked with Milvus to ship the very first C# client, and Quadrant will be coming soon. So I'm going to switch over to my computer and show you a quick demo on how we built a customer service chatbot inside of the eShop application. So we're back on the eShop website, and I want to give you a fun fact about this demo. Every single image and every single product catalog that you see on the page was generated using AI. But I'm going to show you the interaction that we built into an existing .NET application to make it more intelligent. So I'm going to launch my chatbot over here, and I'm going camping this weekend. So I'm going to ask for suggestions. I'm going camping. What do you suggest? So as you can see, I have a list of items that have popped up with rich images and rich descriptions. I want to add a couple of these to my cart. So I'm going to use a very natural language that I would use in a store because I like the tent to number 1. I like the backpack, that's number 3. I'm going to add those to my cart. So I'm going to say, can you add the first and third item to my cart? So both items were added to my cart. And as you can see, we have a very natural response. And if I go over to my cart, we have both items and I'm ready to check out. So let's go and see what makes this all magic under the hood. We're here in Visual Studio so I can show you some code. In our existing application, we added a route that queries our catalog using AI. This is achieved by creating an embedding from the chat search and then ordering it by cosine distance. What this means is that we are ordering the results from the closest to the farthest in relevancy. Only the chatbot is able to access this endpoint, and I'm going to show you how we do this. In our chatbot, we have a set of semantic functions that tells the AI what to do. So for example, this semantic function gets a description. The AI invokes the search catalog function and hits the get semantic relevance endpoint that I showed you earlier. So just in a few lines of code, you too can make your app intelligent. Before I hand it back to Damien, I wanted to share how developers at Microsoft and across the globe are leveraging AI to personalize their user experiences. One of the most popular AI assistants in the world is Bing Chat. It is setting industry standards on how you build large-scale AI applications. And guess what? It's built with .NET. In addition to Bing, we also have developers across the world who are leveraging AI within their .NET applications. Stack Overflow builds on .NET. Now they trust .NET to bring AI-powered offerings to their community. We're also collaborating with industry partners like Intel to push the performance boundaries across a set of scenarios.
Thanks, Maria. It really does seem like it's that easy to integrate AI with .NET.
It is that easy.
Thank you very much.
Thank you, Damien.
I think we should go off and find Glenn and Fowler to talk about cloud native. We aspire to make .NET the best platform for building cloud native applications. ensuring developers can build observable, resilient applications that scale along with their business needs and are easy to manage using rich telemetry. The .NET team has been working really hard this release on lots of features in this space, so I want to hand over to Glenn and Fowler to tell us more.
Thanks, Damien. First thing I want to call out is a large set of capabilities that we build up in conjunction with a set of high-scale service partners here at Microsoft. People doing billions of requests with millions and millions of customers. We went through several code bases and we tried to extract the most useful components to help you building cloud services today. There's a lot in there, but it falls into basically these 4 categories. Resilience, particularly built on the new version of Poly that we collaborated with the Poly team on. Health checks, testing and fakes, and observability. You should check out all of this if you're building cloud services, but I want to particularly talk about observability. .NET has always had deep integration with OpenTelemetry. And in .NET 8, we adopted OpenTelemetry semantic conventions and had a ton of new metrics and data points for you to be able to observe what is going on in your application. As you can see on the screen, we created this beautiful Grafana dashboard for you to be able to grab and get started quickly with seeing what's available in .NET 8. And then because we're betting on open standards or because of their own or existing deep integration, you're also going to be able to get that data with App Insights or whatever APIM vendor that you're using today. Now let's change focus and talk about containers. Containers are the unit of deployment for the cloud. And because of that, .NET is always working on improving our container story. In .NET 8, we've hardened the security of our default container story by making sure that you're not running as root in containers. We've tried to improve the size of your containers and made sure that all of that works with our existing SDK publish feature to try and get you into containers and into a registry as fast as possible. Let's zoom in a little bit on the size. So not only does size help with attack surface area by not having as many dependencies inside your application, it also helps with deployment speed and density and many aspects of building a cloud native application. In this image, you can see on the left the improvements we've made and options you have for just the size of your base images. We worked hard with partners like Canonical in this case to make that real. And on the left, you see all the runtime options for different sizes of your .NET application inside those containers. And if you look far to the right, you see this really tiny application running in the chiseled AOT. And what that is our AOT investments over the course of .NET 8. So AOT stands for ahead of time. And that's when you compile your application to native code and get a small self-contained executable that you can run. We think that partners really nicely with Cloud Native because you often have small microservices that you want to run lots of in a cluster. And so in .NET 8, we created a sample application that was meant to simulate a small HTTP API. The idea being that we model a small microservice that does something useful. And then we try to get a better profile for that in terms of publish size, working set, and startup. So you can see here where we started. We had nearly 100 megabytes and 90 megabytes working set. And then now, at the end of .NET 8, you can see the massive improvements that we've made, all less than 10 megabytes on disk and a very small impact to your request per second. You're going to be able to pack many more of these onto a cluster than what you were able to before. But this is still just phase 1 of AOT for us. This is a HTTP API using a database, so you can still do real work. But larger libraries like Signalar and Entity Framework and a lot of ecosystem packages aren't ready for an AOT world yet. And so you're might have to wait, and we're going to continue to work on this from release to release. Show you what this looks like and talk about that a little bit more. David is going to demo AOT in one of the eShop services that you've seen.
Thanks, Glenn. The team has been hard at work making native AOT work for ASP.NET Core services. In .NET 7, we started the AOT journey with console applications. And in .NET 8, we made a lot of progress making ASP.NET Core applications ready for publishing to AOT. So let me show you an example of the eShop application. We're going to take one of these services and native AOT compile it. The Basket API is a very simple microservice that uses gRPC and Redis. I did one small change to my application. I set publish AOT to true in my project file. And that's all you have to do to AOT enable any application. Now, it's not that easy because if your dependencies aren't native AOT compatible, then it won't work. Let me show you an example of the publish size of this application before native ALT. So to get this application, I made this application a single file publish. I set publish single file to true. And the end result was 102 megabyte binary. This contains the entire framework and every dependency required to run the application, but it's not very small. ALT lets us trim the application to its bare minimum dependencies and compile to native code so it doesn't have any dependencies on the runtime and just on the OS. All right, so I made the application publish ALT true. Let's head to the command line and run .NET publish. It's compiling. It's going to build the application to IL, and then it will turn that IL into native code. So there's no JIT. You'll see a sentence saying generating native code soon. And there it is. All right. During this phase of compilation, you will get warnings if your app or any of your app dependencies are not native ALT compatible. So if you're using libraries like AutoMapper, AutoFac, Entity Framework, you'll get a ton of warnings that typically are really hard to fix. But remember, this is a journey. And as Glenn said, we're working with the ecosystem and partners to make libraries more ALT compatible as time goes by. So I expect there to be a slow progress in getting that out. All right, the app finished compiling, and the app that was 102 megs is now 23 megabytes.
That's amazing. And you're going to be able to fit a lot more of those onto a cluster when you're trying to achieve high-density cloud-native apps.
Yep.
Well, thank you, David. And thank you for watching our whirlwind tour of the cloud-native features that we have in .NET 8. And back to you, Damien.
Thanks, Glenn. Fowler, I know you and I worked on the AOT feature. It's fantastic to see all that come together at the end of the release, and I'm really looking forward to customers getting that stuff. You've seen so much great content about cloud-native work in .NET 8 today. Please check out the rest of the talks that are going to be available during .NET Conf about this. The team's worked really, really hard on this stuff in .NET 8. Up next, let's hear from Vestas Wind Systems, who are harnessing .NET's cloud-native capabilities to build more efficient solutions in sustainable energy.
Here in Vestas, as a global leader in sustainable energy, through our wind energy and hybrid projects, we have kept 1.9 billion cubic tons of CO2 out of the atmosphere. Fast innovations require digital twins at scale, and that is where we lean on the .NET technology. The cloud-native capabilities of .NET effortlessly orchestrate our workloads, requiring 400,000 cores and petabytes of data. It is a natural fit for our high-performance computing, like our Vestas turbine simulator application. With Web API, we could easily integrate existing systems and streamline our data exchange to meet our requirements. With Blazor, we used our existing .NET skills to develop an interactive admin dashboard. We use Azure Functions for serverless event processing, letting us focus more on the code than infrastructure. And when it comes to understanding performance or troubleshooting, application insights give us a vital telemetry on our distributed .NET APIs. Sustainability is always front and center for Vestas. Through contributions to the open source carbon-aware SDK written in .NET, we dynamically allocate Azure resources based on carbon intensity, which aligns directly with our sustainability goals. .NET provides the scalability and flexibility to run applications that help Vestas make the world a greener place.
It's great to see .NET increasing performance while reducing environmental impact, aiding in Vestas' sustainable efforts. Now, with that being said, we are always seeking to innovate as the cloud-native landscape continues to evolve and delight developers. The most important aspect of that is listening to you and having you tell us what you need. As we've talked to customers and partners, both internal and external, here's what we've found. Cloud computing is fundamentally hard. Getting started is really hard. Developers need to make a lot of choices, and .NET today does not have a golden paved path available to you to build cloud-native apps. And that is why we are so excited today to announce .NET Aspire, a new stack for building production-ready, observable, distributed applications with .NET.
ASP.NET. I used to work on that. I think Aspire is one of the biggest innovations in .NET, in the last couple of years. I'm very excited about this.
Awesome. Well, Glenn and Val are going to tell us more.
Thanks, random guy. We are happy to be able to show you Aspire for the first time. The team has been working really hard on it, and we've been really trying to streamline cloud native development and try and solve some of those problems that Damien talked about earlier. So I'm going to give you a bit of a whirlwind tour of some of the features of the stack, and then David is going to take it away to show you how it all comes together in a demo in eShop. So the first thing I want to talk about is the components. Aspire includes a curated set of components to try and address some of that choice and complexity problem that we heard about earlier. Components are configure client libraries for resiliency, telemetry, configuration. They all have a rich schematized configuration system. They don't wrap the client library, but they configure it for production readiness in a cloud environment and get it into DI as much as possible. So if you're going to use SQL Client, you're still using SQL Client, but it's configured to be ready with timeouts, resiliency, and so on. Next, I'm going to talk about the developer dashboard. So the developer dashboard, we've discovered, is really your first line of debugging for a distributed application. It's become extremely useful for us in debugging all the apps that we've shown you today. And we think it's going to become the centerpiece of your debugging efforts and diagnostics efforts as you're running applications as well. And then finally, you can run an entire distributed solution in a single command. You can express your application topology in a language you're familiar with the concepts that you're familiar with, like references. And then you can deploy it to the cloud, either using things like the SDK container build we talked about earlier, or via integration with other ecosystems like Radius, AZD, or Terraform to map your application needs to a cloud environment. But that's a lot. And to show you what that really looks like in an actual demo, I'm going to hand you back over to Fowler.
All right, Glenn, thank you. Let's talk about Aspire. If you've been paying attention during the keynote, you would have noticed this little purple triangle hanging out in various slides. That's the Aspire icon, and this is the Aspire App Host project. I can add Aspire orchestration to any existing .NET solution by either right-clicking, going to Add, and clicking Add Aspire Orchestrator Support. That lets me add these two projects, the solution.apphost and service defaults, to my current application. I can also go on the command line and do .NET new Aspire to create these projects as well. All right, let's dive into the AppHost project and see what it does. Here's my program main of the AppHost project, and I am constructing my application by adding containers and projects. And as Glenn said, I am adding a reference to these containers from my project. Not once have I had to mention a connection string, a URL, a port. That's all handled for you by the Aspire orchestration process. So you can see right here, my basket API is referencing the Redis container and the one for RabbitMQ. That will inject the appropriate connection strings into the application when it runs. Now, eShop has about 13 or so projects, and they're all wired up in about 63 lines of code. Pretty cool, right? Normally, I would have had to use Docker Compose, which requires me to build container images during development for every single project. What a pain. Also, I could have gone to Visual Studio and configured multiple startup projects, and that only helps with launching. It doesn't help me configure connection strings or ports. Aspire handles all that for you. I can run the entire application in a single run of the app host. Let's do it. I ran the app host, and it launched the orchestrator, which will launch the containers and projects and pop up this beautiful dashboard. The dashboard shows me an overview of all the projects, containers, executables in my entire application. It shows me things like errors that may be occurring in the logs. I can see a ton of errors. I see the endpoints for my application. I can visualize environment variables. I can see values being passed in. I can even look at console logs. It's pretty awesome. Let's run the application and create traffic to see what the app is actually doing. So I'm going to buy a watch so I can tell time. I'm going to log in right here now with my super secure password. And I can add to cart, to bag, and check out and then hit place order. So the app is functional. That was cool, but let's see what happened behind the scenes. In the dashboard, I can click on traces to see a list of requests that happened for the application. I want to see what happened during checkout. This trace hit 5 services. Out of the box, the Aspire dashboard shows me a distributed trace of the operation, which shows me calls to every dependency, including Postgres, Redis, RabbitMQ. And I can also see that there's a lot of stuff going on, a lot of queries happening. Let's check on that later. But how did the dashboard get this info in the first place? Let me switch over to a brand new Aspire project in Visual Studio. So I can do File New, search for Aspire, and there's 2 templates. I'm going to create the Aspire starter application. We can see familiar projects. We just learned about the Aspire app host, but there's a new project here called aspire.servicedefaults. I'm going to dig into the extensions CS file, and I see a method called add service defaults. The intent behind this method is that it's called from every single application to configure the default things like telemetry, health checks, service discovery, and resilience in every application. We are by default using OpenTelemetry. We're going to wire up default traces for HTTP, gRPC, and all the things required to build a cloud-ready application. We also expose health check endpoints by default so that any modern cloud platform can get the health of your application out of the box. Now, this project is meant to be yours to customize. It's in your app so that if your company or team has their own defaults, you can express those as part of your service defaults application. Let's take a look at the program CS for the Blazor project. I'm using the Redis output cache Aspire component, passing in the connection name cache, and I'm also wiring up a typed HTTP client, hitting the backend service API service. How did this work? If you recall, if you look at the app host project, we get to name our components, our resources. So in the app host project, I named my Redis container cache, and I named my API service, API service, API service. I can use those names in the project as the connection names for both Redis and for the HTTP endpoint in my Weather API client. This takes away the pain of having to find ports and connection strings. That's all handled for you out of the box. This demo wouldn't be complete without deploying to a cloud. So let's see what that looks like. I'm going to pull up the command line, and I'm running a preview build of the Azure Developer CLI. This build understands Aspire projects natively, so I can run azd init, and it will ask me to scan the code in my current directory. And it will eventually find the Aspire project. Awesome. So it found my Aspire app host project. And if you recall, my app host project describes my app's dependencies. So we're going to confirm that. We're going to confirm one more thing. We're going to expose this one endpoint. And we're going to call this the Keynote df Keynote. Perfect. Now I can run azd up. And it will ask me a couple of questions, like where do I want to deploy it to. I'll pick this. I'll pick that. Awesome. That kicked off the process of deploying it to Azure. So it took about 5 minutes to deploy that application, and I have one here prepared and ready for the Keynote. So let's jump to the resource group and see what got created in Azure. So with just the Aspire project, the Azure Developer CLI was able to understand the application, its dependencies, and it deployed containers to container apps and also deployed the Redis instance to Azure. And the app should be running. Awesome. One more thing. The weather endpoint is the important one. And we're up in Azure with just 2 commands. All right, we just saw how you can add Aspire to existing projects, use the dashboard to gain a deeper understanding of your application, use Aspire components to make calling dependencies robust and observable, and of course, deploy it to any cloud. Back to you, Damien.
The first preview of .NET Aspire is available today, and we can't wait to see what you build with it. It's open source on GitHub, so please do let us know what you think. Let's go catch up with Gaurav.
Thank you, Damien. It is always so humbling to be part of these keynotes and to see the outcome of so much hard work from the teams across Microsoft and the community members. There is so much in .NET 8 and it is available today. So head over to the .NET website to get started. Alongside the release of .NET 8, we have also released the 17.8 version of Visual Studio 2022, which supports .NET 8, the latest C# 12 features, and improves developer productivity across the board, including several new enhancements to GitHub Copilot. Go to visualstudio.com and download it today. In collaboration with FreeCodeCamp, we recently announced the Foundational C# certification. Co-authored by Microsoft and FreeCodeCamp, these certifications help you gain practical skills and knowledge to start building applications with C# and .NET. This certification is completely free and is available today on FreeCodeCamp. Now, speaking of learning, Microsoft Learn is another great platform to learn all things .NET. If you are new to .NET, looking to add a new skill to your developer toolbox, or just looking to brush up on the latest and greatest in .NET, then head over to Microsoft Learn, where we are launching new and updated content for you to start learning today. For the rest of this conference, we have a packed and exciting agenda with sessions from teams across Microsoft, our partners, and the .NET community. I want to close out this keynote by thanking all of you for joining us today, giving us your feedback, and all the support that you provide around .NET. Thank you and have a great .NET Conf.